Good morning. This is reading week 7 for Physics 2211. The first big physics idea we discussed was the energy principle. We looked at how the change in energy is the sum of the energy transfers in and out of the system. One type of energy in particular we discussed was kinetic energy. Kinetic energy equals 1/2 times mass times the magnitude of velocity squared. We can connect this to momentum through some algebra and substitution. First, we multiplied the expression m by m over m, or as an old teacher of mine used to call it, a clever one, to get k equals 1/2 m squared times v squared over m. Substituting momentum squared for m squared times v squared, we get that kinetic energy equals 1 over 2m times momentum squared. One thing the video stressed was that unlike forces, energy is a scalar quantity. Its dimensions are mass times length squared over time squared, otherwise known as a joule. Furthermore, another important thing to note is that an energy gain is really just a loss of energy from the surroundings to the system. The second big physics idea was work. Work is when forces act to transfer energy in and out of the system. Work fully depends on the magnitude of the force and the distance spent applied. However, force in the wrong direction does not contribute to the work, so we must be specific about what component of force is actually doing the work. Thus, the formula for work is the magnitude of force times delta r, which would be the distance, times cosine theta, with theta being the angle the force makes with the direction of motion. This is also called a dot product. Along these same lines, if the force is perpendicular, there is no work done. One set of relationships that illustrates how interconnected everything is that if the force F opposes the motion, the system slows down, meaning there's a negative change in kinetic energy, a negative delta E, there's a transfer of energy out of the system, and the work was negative. Two examples were done with work in the video, one with a ball and one with a box, I believe. These really showed an in-depth explanation of how to solve these problems efficiently and greatly helped in my understanding. The last video dealt with work by non-constant forces. We can break up the path into small places where the force is fairly constant through the interval to get the calculus representation of work equaling the integral of F with respect to r, with limits of r initial and r final. In terms of what I was already familiar with, I had previously learned about energy from my high school physics class. However, although I was familiar, I completely misremembered the formula for work, which led to me being very confused for a good part of the work video. Therefore, even though I've had the most exposure to this concept, it's likely remained the most difficult for me as I have to reform the concept in my brain to be work equals force times distance applied. The concept of energy, though, really caught my attention because as a chemical engineering major, I'll be dealing with energy a lot, trying to determine if reactions are happening or not, the properties of material given a specific energy it has. I'm looking forward to learning more about this through the next week of lectures. As for resources that have helped me understand this, one in particular is the organic chemistry tutor on YouTube. Despite what his username suggests, he also makes videos about physics, and they're extremely helpful. He goes through practice problems and explains each step with very careful thought, so it's nice to watch when you're absolutely lost like I am sometimes. Another resource is the Physics Libre text that I've mentioned before. It has an entire section on work and energy, and the explanations are pretty clear and simple, which is nice when you need to read things over and over again. It also shows how it's connected with lots of helpful diagrams. This has been reading week 7 for Physics 2211. Thank you for listening.